So we're going to find the radius of convergence and the interval of convergence for the following Taylor series. And this is one of our common ones, and actually it's the sum of a geometric series. So 1 plus x squared plus x cubed plus dot dot dot. And what we want is we want to write it in summation form. X to the n from n equals 0 to infinity. Now, to find, and if you don't know this one offhand, just do your derivatives at 0 and find your terms. Now we're going to apply the ratio test, limit as n goes to infinity, of a sub n plus 1 over a sub n. So the limit as n goes to infinity of x to the n plus 1 over x to the n, which actually just becomes x. So we end up with the absolute value of x times the limit as n goes to infinity of just 1, which is 1. So we end up with the absolute value of x, and we want this to be less than 1. So right there we have our radius of convergence. It has a radius of convergence of 1. But let's say we wanted to find the interval. Then we know that x must be in between 1 and negative 1. And now we need to check our endpoints. So first one we'll check, let's check x equals minus 1. So we're going to plug that in here. If we do that, that would give us the series negative 1 to the n from n equals 0 to infinity. This is an alternating series, but it just alternates between 1 and negative 1, which means the sum alternates between 0 and 1. We can see that the limit as n goes to infinity of a sub n does not equal 0. So this is divergent, which means we do not want to include negative 1. Let's do the same thing for 1. If we put 1 in, we get 1 to the n equals 0 to infinity. We can use pretty much the same test. The sum of 1's is going to go to infinity. If we wanted to make a formal argument, I think the easiest would be to say, hey, our sequence does not go to 0. This diverges. Therefore, our interval of convergence is not including, negative 1 to 1, not including either endpoint.